Okay, our objective for today, I can factor quadratic trinomials with leading coefficients greater than 1. Let's read together, 1, 2, 3. I can factor quadratic trinomials with leading coefficients greater than 1. Who notices that it's still the same objective from yesterday and the day before? Yes, right? The only thing that's different today is the fact that we're going to be looking at special products. So as your title for your notes, I want you to write this. Everybody look up right here where it says special products. Write that at the top with your title. If you wrote quadratic trinomials as your title, write that underneath special products. Why? I'm going to show you a couple patterns that you need to know in order to make it easier for you when factoring. Okay? Right. All right, so here we go. So we're still looking at quadratic trinomials, but like I said, we're looking at special products today. And we don't need a Fourier model because we already know what quadratic trinomials are. We know that they're expressions with 3 terms, highest degree 2. We know what they are not, and I gave you guys critical attributes. Do we know the steps to factor? Yes. First, identify the GCF, open 2 parentheses, factor the first term, use the diamond for the last 2 terms, write your factors, and check. Okay, so today, like I said, we're looking at 2 things. The first thing, on your Q side of your notes, I want you to write this down. First thing that we're going to be looking at is perfect square trinomials. That's the first thing. And there's a pattern as to how to factor those. On the Q side, you don't need a definition. I just want you to write the vocabulary I'm going to be using. The second thing we're going to be looking at is, you can leave a space and write this down, difference of squares. Yes, on the Q side, of squares. So how many different things are we looking at? 2, perfect square trinomials and difference of squares. And I'm going to show you the difference from one to the other coming up next. Okay? All right, so with that said, for this next part, I just want you to pay attention. You don't have to write anything down. I need you guys to focus, please. Here it goes. So, for this next part, check this out. Pens down, eyes up here. So, at the beginning of the year, I remember when we first introduced polynomials, I showed you guys how to multiply binomials, and I showed you how to multiply using a area model. Is that correct? So check this out. And I covered something that went like this. If I had 12 times 12. 12 times 12, we know that's 144. And I said 144 is known as a perfect square. Perfect square number. You don't have to copy this. You're just paying attention. We already covered this. Why is it a perfect square? Because I said, if I find the roots of 144, the roots are what? 12 by 12. Is this a perfect square? Yeah, because the sides measure the same. Are everybody there? Okay. However, check this out. I can rewrite 12 as 10 plus 2 times 10 plus 2. Do you agree with that? Yes, 12 is the same as 10 plus 2, and 12 is the same as 10 plus 2. Now check this out. If I was to use the area model, kind of like I did here, but for these, it's going to look like this. 10 plus 2 times 10 plus 2. Remember that? So check this out. Just pay attention. You're not writing anything down. What is 10 times 10? 100. What is 10 times 2? 20. What is 2 times 10? 20. And what is 2 times 2? 4. Now, before I move on, give me a second. Before I move on, who notices that 100 is a perfect square? Because the dimensions of this is 10 by 10, isn't it? And isn't this a perfect square? How about the 4? Isn't 4 a perfect square? Because it's 2 times 2. Everybody with me? The 20 is not a perfect square because it's 2 times 10, and this one is 2 times 10. Are we there? Now check this out. I'm going to rewrite this. I'm going to write 100 plus, what is 20 plus 20? That's 40. And then at the end, I'm going to write plus 4. Okay? So now check this out. Just pay attention, please. Everybody look up. There's a pattern as to how to check to see if this is a perfect square. Here goes the pattern. Square root of the first term. What is the square root of 100? 10. Square root of the last term. What is square root of 4? 2. What is 10 times 2?
20.
And if we double that, that means we multiply times 2. That should give us the middle term.
Oh.
Did everybody see that?
Yeah.
Okay. Now you're saying, Mr. Q, does that work with all perfect squares? Let's find out. Check this out. Let me try it again. Now I'm going to try it with two different numbers. I'm going to try it with 14 times 14. Okay? So if I was to multiply 14 times 14, let's see, 14 times 14, that's 6. I got 1, that's 4, that's 5, and 14, that's 196. 196, right?
Yeah.
So therefore, we know that this is 196, but we can rewrite this as 10 plus 4 times 10 plus 4. Is that correct?
Yeah.
So check this out. So if I use the area model, I got 10 plus 4, you're just paying attention, times 10 plus 4. So what is 10 times 10? That's 100. 4 times 4, that's 16. And now I need to worry about the other ones. 10 times 4, that's 40. And this is 40. So I'm going to rewrite this. This is 100 plus what?
It's 80.
80. And then at the end, plus 16. Let's see if the pattern works. Let's see. What is the square root of the first? 10. Square root of the last?
4.
4. What is 10 times 4? 40. And if we double that, it gives us the middle term. Do you guys notice that?
Yeah.
That's how we can check that it is a perfect square. If we get the square root of the first, the square root of the last, multiply those, and then times 2, it should give us the middle term. Once again, the pattern is square root of the first, square root of the last, multiply those 2, and then double it. That should give us the middle term. Square root of the first, square root of the last, multiply those 2, and double it. That should give us the middle term. Okay? Now check this out. What numbers do you see here? 10 and 2. So check this out. So by finding the square root of this one and this one, if it is a perfect square, I can write this like this. 10 plus 2 times 10 plus 2. Those are my two factors because I just use these two numbers. So what are my factors for this one? 10 plus 4 times 10 plus 4. So that was a pattern that I wanted to show you. That's for the first part, the perfect square. This is just using math. Let's use algebra. Copy this example down, please. Example 1. Copy the words and copy the polynomial. It says, example 1a, determine whether each trinomial is a perfect square. If so, factor. If not, explain. Once again, it says, determine whether each trinomial is a perfect square. If so, factor. If not, explain. The trinomial that they give us is 81x squared plus 90x plus 25. 81x squared plus 90x plus 25. Copy that. Writing utensils down. Let me go over this one first to make sure that you understand. I just wanted to go over a pattern, but let's answer what they're asking. It says, determine whether each trinomial is a perfect square. So first let's check if it's a perfect square. How do we check? What was the pattern? Square root of the first. What is square root of 81? That's 9. What is square root of x squared? That's x. How do we get x? Check this out. Everybody look up. I remember when we covered square roots that we said the index number that we don't write here is a number 2. If there's a variable inside, such as x squared, what happens to the exponent and the index? They divide, don't they?
Yeah.
What is 2 divided by 2? 1. That's why I get x to the first. There it is. Are we there? What is the square root of the last? 5. So the pattern says square root of the first, square root of the last, then we multiply them. What is 9x times 5?
45x.
45x, and at the end we do what? Times 2. Did we get 90x? Yes, then this is a perfect square. If it is, it says, if so, what do? Factor. So check this out. This is how we factor. Everybody look up, please. 9x plus 5, and if it's a perfect square, we just do it again, right? 9x plus 5. What's another way of writing this? 9x plus 5 to the second power. And we're done. Copy that, please. For right now, copy both. Okay, so let me see the pattern once again. To check to see if it's a perfect square, I need to get the square root of the first term. There it is. Square root of the last term. There it is. Multiply both of them and then times 2. That should give us the middle term. If it is, therefore, my factors, I just use these two numbers, these two values, and it's going to be 9x plus 5 times 9x plus 5, which can be written as 9x plus 5 squared. Now, some of you are asking, Mr. Q, what if I multiply 9x times 5, that's 45x, times 2? What if this was not 90x? Then guess what? It is not a perfect square. And you're done. You don't have to factor. Everybody with me? But you will have to explain. How would you explain? Well, it's not a perfect square because when I get the square root of the first and the last and I multiply times 2, does not equal to the middle term. Everybody with me? You need to explain it. All right, copy this next one, please. Example 1B. 1B. You don't have to copy the words for this one anymore. Just copy the trinomial. 9x squared minus 15x plus 64. 9x squared minus 15x plus 64. Let's do this one together. Let's see. Our pattern. Let's see if we got our pattern down. Square root of the first. 3 what? 3x. Square root of the last. 8. Multiply those two. What do we get? 3x times 8, that's 24x. And then double that. That should give us what? 48x. Is that this? No, so then you write not a perfect square. And then it says explain why. You're going to write comma because. Okay, before you write it, think about this. Your BFF is not here, right? They didn't come to my class. And tomorrow you see them, and then they're going to be like, oh, man, yeah, this is not a perfect square. Why? Think about it. Why is this not a perfect square? How are you going to explain to them? Think about it. Why is this not a perfect square? All right, explain to your neighbor. What would you tell your BFF? Something like this. Not a perfect square because if I get the square root of the first and the last term and multiply them and then double that, it does not give me the middle term. Everybody got it? That's simple. That's simple of explanation. The square root of the first and third term, multiply, then double, does not equal the middle term. Yes.
Well, can't we just show it work?
Copy this down. Example 1C. 1C. Copy that, please. 36x squared minus 10x plus 14. Okay, let's do this one together also. 36x squared minus 10x plus 14. Let's see the pattern. Square root of the first.
6x.
6x. Square root of the last. Oh, that is not a perfect square. So therefore, this is not a perfect square. Because, think about it, why isn't it a perfect square? Think about it. All right, share it with your neighbor, please. So, look at this one. Look at the third term. What is the third term here? 14. Is that a perfect square? No, because we couldn't find the square root. Right? Because if we find the root, we can find a root, but it's going to be a decimal estimated, right? It only works if it's a perfect square on the first and the last term. Do another one. Example 1D. I'm sorry, 2a, sorry. Example 2a.
Yeah.
X squared plus 4x plus 4. Do that one by yourself. It says, check, see if it's a perfect square. If so, factor it. Go. Okay, let's see. Let's go with the pattern. Square root of the first term, x. Square root of the last term, 2. What is x times 2? 2x, double that. Does that give us the middle term? So it is a perfect square. If it is a perfect square, we need to write the factors. My factors are x plus 2 times x plus 2, which is x plus 2 squared. Answer, if you got that by yourself? Okay. Let's do another one? Sure, let's do a bigger number. Here we go. Copy this one down. That's if it's not. Here we go. 2b. Copy this one. X squared minus 14x plus 49. X squared minus 14x plus 49. Go. All right, let's see. Here I threw a little curveball. See if you catched it. Let's see. Caught it. My bad. No, catched it. I'm going to say catched it. Yes. Tell your language arts teacher. How about that? Here it goes. Square root of x squared. What is that? X. What is square root of 49? 7. Let's see. What is x times 7? 7x. Double that. Does that give us 14x? It doesn't give us 14x? Not the, you're like, not the negative. But let me ask you this. Pens down, eyes up here. Remember when we covered roots? What is the square root of 49? Plus, minus 7. Why? What is negative 7 times negative 7? And what is 7 times 7? So therefore, what would be my factors if this is a negative? X minus 7 and x minus 7, which could be written as x minus 7 squared. Let's find out. Okay, check this out. So this is my answer. Let's double check to make sure that it is right, because some of you are still wondering, but how does that work, Ms. Q? Well, let's find out. What is x times x? X squared. X times negative 7. Negative 7x. Negative 7 times x. Negative 7x. Negative 7 times negative 7, that's positive 49. Combine like terms. What is negative 7 and negative 7? Negative 14x. Does this give us the same that we started with? Yes, that's how you check it. Okay? Yeah, let me repeat that again. Here it goes. If the pattern worked here, and it gave us this, and this is a positive, both factors will be what? Positive. If the pattern works here, and it gives us this number, but this is a negative, then both factors are negative. Let's do another one. Example 2c. Copy that one. 9x squared minus 6x plus 4. All right, let's see. For this one, guys, focus, please. Here we go. Square root of 9x squared, that's 3x. Square root of 4, that's 2. What is 3x times 2? 6x. But at the end, don't forget to double it, and that should give us 12x. Is that equal to this? No, and therefore it's not a perfect square.
Square root the first and last, you find.
And you know what to write after, right? Yep. Okay, let's go to the next one. Copy this one down, please. Hold on. Everybody's eyes up here? Really quick. Now, they're going to give you something like this. First of all, you need to start writing down information. Don't write this problem down, just pay attention. They're going to talk about a problem-solving problem using factoring. A rectangular piece of cloth. If they talk about rectangular piece of cloth, what are you going to draw? A rectangle. So draw the rectangle. And they say the area for that tablecloth is 16x squared minus 24x plus 9. And then afterwards it says, the dimensions, that means the measurements of this tablecloth need to be in a binomial. Look at this. Does everybody see that? A binomial. Here's a binomial. It needs to look something like this. And then at the end it says, find the perimeter. How do we find the perimeter of any figure? Add all sides. So therefore, to find the perimeter, we need to multiply times 4, whatever the dimension is. Is that correct? Yeah. You're saying, Mr. Cupid, how do we know the dimensions? Well, they give us the trinomial. Can't we come up with factors of this? Yeah, so let's try first to see if our pattern works, yes? Okay, so what is the square root of 16x squared? 4x. What is square root of 9? 3. What is 4x times 3? 12 times 2? 24. And it's a what? Negative. So what are my dimensions? 4x minus 3. 4x minus 3. Is that correct?
Yeah.
So, but for the perimeter, what do we need to do? Multiply that times?
2.
Times 4. So 4x minus 3 times 4. So that gives me, let me see, 16 minus 3. Oh, 16 minus 12, sorry. 16x minus 12. Sorry. The perimeter. 16x minus 3. How do I get the 4x? Square root of 16x squared is 4x. Well, let's see. What is 4x times 3? That's 12 times 2. That's 24, isn't it? How do we find our factors over here? Watch. 7, x times 7, that's 7x. Is that correct? And my factors are what? X minus 7, x minus 7. So check this out. So the perimeter is 16x minus 3. However, they want us to evaluate when x is what? 11. So I write P equals 16 times 11 minus 3. What is 16 times 11? 176. Very good, Mel. Minus, oh, and this is 12. My bad. This is 12. Minus 12. What is 176 minus 12? 164 inches. And we're done. Okay? All right. So now check this out. So pretty much all you have to do is factor out, find the perimeter, and substitute to find the dimension. Yes? Yes. So now check this out. Yes. All right. So we're done with perfect squares. Now let's go to the next one. Check this out. Copy this one, 4A. Don't copy the words, but on 4A, I want you to write these two things. Difference of squares. Focus, please. Difference of squares. 11x squared minus 4y squared. 11x squared minus 4y squared. And right away, you notice that this is not a trinomial. Is that correct? Difference of squares. Difference of squares. 100x squared minus 4y squared. Pens down, eyes up here. Who notices that this is not a trinomial? Right? Is this like these that we've been looking at? No. So check this out. Whenever you get to these and it's a binomial, first of all, the word difference, what does that mean? Subtract. Subtract. So first of all, check. Does it have a subtraction? Yes. Is it a binomial? Yes. So now check this out. This is how easy this is. What is the square root of the first term? 10x. What is the square root of the last term? 2y. If you are able to find the square root of both and it's a difference, then you're done and you write your factors. Here are the factors. This is 10x plus 2y and the other one is 10x minus 2y. And we're done. Because it's a difference of squares and that's the pattern.
So long we add and get a one.
Right. Okay? All right, before you leave, last one, just pay attention. Here you go. Look at this one. You don't have to copy, just pay attention. Here it goes. 3p squared minus 3p to the fourth, q to the fourth. Square root of 3p squared. There isn't a, so therefore this is not a difference of squares because this is not a perfect square. That's all you have to write. Homework. On page what? 518, numbers 33 odd. Have a good one, guys. Enjoy your homework. See you guys tomorrow.